Good morning, children. Today we are going to discuss about a new topic within chemical bond, that is hybridization. Before going to hybridization, let me recapitulate what we have studied in previous class. That is valency bond theory. Valency bond theory is based upon four factors there. First one is atomic orbitals, as well as electronic configuration, overlapping of orbitals. The last factor is nothing but what? Hybridization. Atomic orbitals already we have studied clearly. Electronic configuration also to some extent we have studied. Next thing is what? Overlapping of orbitals. In previous class we have studied how many types of overlappings can we get exist. SS overlapping, SP overlapping, PP overlapping. Due to these various overlapping, three overlappings, two types of bonds will form, that is, one is sigma bond, other one is pi bond. What is sigma bond? Sigma bond is nothing but what? End-on-end overlapping or head-to-head overlapping. What is called as pi bond? Side-by-side overlapping, if it is taking place, it is called as a pi bond. Perpendicular to internuclear axes. When the bond happens, that bond is called as pi bond. Sigma bond is the strongest bond, pi bond is the weakest bond. When it comes to shape of the molecule, will be decided by what? By sigma bond only. When it comes to pi bond, it does not decide any shape of the molecule. Sigma bond can be localized between two atoms which are participating in bond formation, whereas pi bond, it can be delocalized with the bonded atoms there itself. This is regarding two types of bond, that is sigma bond and pi bond, where within the molecule if multiple bonds are existing. And already we have studied in postulates or important points of valency bond theory is greater the overlapping, strength of the bond decides that the strength of the bond will be more. It is the strongest bond. Weaker the overlapping, it gives a weak bond there itself, which decides directional property. Except the s orbital, remaining p orbital will have certain direction. In specified direction, a bond can be get formed. Whereas s orbital, which is existing in spherical shape, electron orbiting around the nucleus in specified orbit or orbital, so bond can be get formed. It does not decide any directional there. To attain shape, p orbital as well as p orbital will play a vital role. That we have studied yesterday, and in yesterday we have discussed about two topics, that is what? Formation of beryllium chloride molecule as well as formation of boron trifluoride molecule based upon valency bond theory. Within this valency bond theory, first three factors are implementing, were clearly explained within this particular valency bond theory, that is atomic orbitals, electronic configuration, overlapping of orbitals. But whereas to give the structure of the molecule, hybridization concept will play a vital role in which bond angle exists. Directional property gives a specified shape for the molecule. So VBD could not explain clearly without hybridization how a specified shape can be formed. Yesterday we have seen it, a beryllium chloride molecule. 2s1 of beryllium is overlapping with 3pz of chlorine molecule to form one bond. That bond is sigma bond. Similarly, 2px of beryllium molecule is overlapping with 3pz of chlorine atom to form one bond. That bond is called as sigma bond. So that the bond angle between them will be in what way? P orbital. All three orbitals, px, py, pz, are mutually perpendicular to each other. So the angle between them must be equal to how much? 90 degrees. But here the angle between beryllium as well as chlorine, beryllium chloride molecule, it is equal to 180 degrees. He could not give clear justification by explaining that particular concept to explain beryllium chloride molecule. Similarly, within boron trifluoride also, p orbitals are mutually perpendicular to each other. Angle must be equal to 90, and their angle must be equal to 90, so that but the boron trifluoride angle is trigonal planar, which angle is equal to 120 degrees. He could not give clear justification. To give it clear proof within valency bond theory, and one more point he could not give clarity. 2s1 orbital is having different energy, 2pz orbital is having different energy, 2px is having different energy, 2pz is having different energy. Variation in energy is existing, variation in bond angle is there, which could not give clear clarity by using valency bond theory without the factor called as hybridization. With this hybridization concept, we can give a clear in which direction the bond is forming. Not only that one, with what angle the bond is forming also will give which gives a specified structure for the molecule. Now we will go to the fourth factor, that is called as what? Hybridization. Now coming to our point called as hybridization. What is called as hybridization within chemistry part? Children, we know clearly hybridization. In biology to some extent, we have studied about hybridization there. For example, plants. If I take a rose plant of red color and a rose plant of white color, combined together, so that what happens? It has its own characteristics. Red plant has its own characteristics, white plant has its own characteristics. When we hybridize those two plants, two characteristics property plant will be arise. For example, red plant, if I am taking it a red rose plant, and white rose plant, if I am mixing together, the characteristics of those two properties, those two characteristics of red rose plant as well as white rose plant will be attained by a new plant having both characteristics, and it gives a color called as pink color rose. That is nothing but what? Hybridization. Similarly, let me give in a technological field there itself. We are having different types of vehicles. Different types of vehicles running there itself. A car. Take two cars. One car which is running with a gasoline is working there itself. Take another car which is running with electricity. Combine those two cars, hybridize those two cars, so that what a new car comes which can have both the characteristics of gasoline it can work as well as electricity also it can work. Therefore, a hybridized car is nothing but which one? It is a car running with both gasoline as well as gas as well as electricity. Similarly, pink rose plant is having similar characteristics of both characteristics of red rose plant as well as white rose plant. In the same way, hybridization can be taking place between orbitals. We know that clearly four types of orbitals are there: s orbital, p orbital, d orbital, f orbital. We have studied clearly about these four orbitals in atomic structure. Now what happened there? Now we come to the definition of this concept. I have taken two orbitals, any two orbitals, s orbital as well as p orbital. In our 10th class, these hybrid orbitals between it can be formed between two orbitals only, that is s orbital and p orbital. S orbital is having its own energy and electrons, p orbital is having its own energy and electron intermixing together. mixing up together those two orbitals. When I am intermixing two orbitals together, a new orbital coming to exist, having similar characteristics of s orbital as well as p orbital. And redistribution, it is having its own energy, it is having its own energy, combined together so that energy will become as what? Equalized energy. A new orbital will form in which energy can be distributed in the form of equal. And rearrangement of electrons will be taken place. Energy distribution has been taken place in equally, and rearrangement of electrons also taking place within a new orbital. That orbital is called as hybrid orbital. That particular process is called as hybridization. This hybridization, children, this hybridization has certain salient features. What are those features? Let me see it. First feature is, first point what we have to keep in our mind is, number of hybrid orbitals, what else we are getting it up, will be equal to number of atomic orbitals. Means how many number of atomic orbitals we are intermixing together, it will be equal to that many number of hybrid orbitals. For example, if I take one s orbital and if I take one p orbital, I am intermixing these two orbitals so that what happens there, a new orbital will be obtained there. Two orbitals will be formed there itself, having one s orbital. Mixing nature of an orbital called as a new orbital having two orbitals. This is one sp hybrid orbital. This is another sp hybrid orbitals. So, how many number of atomic orbitals are mixing it up? That many number of hybrid orbitals we are attaining. That is first point what we have to keep in our mind. Coming to second point, these orbitals will have equal energy and shape. The energy within this orbital is different, within this orbital is different. When they are intermixed together, this new orbital has been, new two orbitals have been formed here, in which equal amount of energy will be existing as well as shape of that particular molecule also shape. It attains equal energy as well as shape of that particular hybrid orbital. That is second point what we have to keep in our mind. Third point, these hybrid orbitals are more effective to form stable bonds. To form stable bonds, hybrid orbitals will play a prominent role. More effectively, they will be participating to attain stable bonds. That the bond should not be breakable. Next point is what? They are directed in space. We have studied in valency bond theory there. Greater the overlapping, stronger the bond. It gives directional property, we have studied there itself. Here these hybrid orbitals can be directed in space. They will be moving in different directions there, depending upon the molecule, so that they can minimize repulsion between electron pairs, between electrons. Why they are moving in different directions, why they are repelled, why they are moving away, such that what happens is what? They are directing in different directions to minimize repulsion force between electrons. In each orbital, electron will be existing, each hybrid orbital will have electrons. So that to minimize the repulsion force between electrons of hybrid orbitals, they will be directed in different direction. It indicates nothing but what? It is showing, it is playing a role called as geometry. Geometrical structure can be obtained based upon this particular point there itself. These are the 4 points which are required to form a molecule called as hybridization. Next thing is what? Some important conditions also we have to keep in our mind. What are those important conditions? First condition is orbitals of valence shell n will be get hybridized, as we are related to 10th class. Orbitals of valence shell whose number is n will be get hybridized. Only ultimate shell electrons, valence shell electrons only will be get hybridized. That is first point we have to keep in our mind as we are dealing towards 10th only. Next point is what? Orbitals undergoing hybridization. The orbital which it is formed a new orbital, hybrid orbital. It will be having equal energy. That is the second condition what we have to keep in our mind. Equal energy will be get existing. Orbital S is having different energy. Orbital P is having slightly variation in energy. These two slight variation energy orbitals mixing up and forming equal energy hybrid orbital. That is the second condition what we have to keep in our mind. Fourth condition, promotion of electron is not essential condition before hybridization. It is not that much essential. What is called as promotion of electron? We are taking a central atom electronic configuration. For example, carbon 1s2, 2s2, 2p2. 2s2 is having 2 electrons, 2p orbital is also having 2 electrons. From 2s2 orbital, if I want to promote an electron from bound state, I want to make it to excited state. That is not that much necessary. Bringing an electron from bound state to excited state before hybridization, it is not that much essential. Within the concept of this one, this particular condition also we have to keep in our mind. Here, hybridization. Hybridization can be taking place between the orbitals which are complete filled orbitals or completely filled orbitals will participate in hybridization. The orbitals in which electron is not existing, they will never participate in hybridization. Orbitals having half-filled as well as completely filled will participate in hybridization. These terms and conditions, important conditions, if we maintain it up and know about these salient features, then we can easily go through with the concept called as hybridization. Okay children, just now we have studied about salient features as well as important conditions to hybridize, to form an hybrid orbitals. We are studying. Next, a little bit more we'll study about hybridization. First question will raise in our mind. What will get hybridized? What will be getting hybridized here? Hybridization can be taken place of two things. That is, first, all pi bonds, all sigma bonds will be get hybridized. And all lone pairs will be get hybridized. What will get hybridized? There are two things. All sigma bonds will be get hybridized as well as all lone pairs also will be get hybridized. And what about multiple bonds? We have seen some molecules in valence bond theory. Oxygen molecule is having multiple bond. Nitrogen molecule is having multiple bond. Oxygen molecule, 1 sigma bond, 1 pi bond. Nitrogen molecule, 1 sigma bond and 2 pi bond. So when that particular relation appears, what happens that within that sigma bond will be hybridized, whereas pi bond will be unhybridized. It won't form an hybrid orbital. Only p orbitals. Why we are taking here hybridization process can be start as we are dealing with 10th class S and p orbitals only. Only p orbitals will be get hybridized. Next thing is what? Single bond is what? Sigma bond. Multiple bonds, if we are taking, this symbol indicates what? Single bond. This symbol indicates what? Double bond, in which one single bond and one sigma bond and 1 pi bond. Here 3 lines are there, indicates triple bond, in which one sigma bond and 2 pi bonds. It gives about multiple bonds. Next thing is what? Electron, region of electron density. These two dots will clearly indicate nothing but what? Lone pair. This 1 dash indicates single bond. 2 dashes indicates double bond. 3 dashes indicate triple bond. Now coming to the region of electron density and hybridization. If two orbitals, two lone pairs, two are participating there itself, then it is called as two region of electron density. If it is there, it is called, it forms one hybrid orbital called as sp. See here, I have taken an electron, a spherical shape molecule, place dumbbell shaped molecule. In which electron is there? In which electron is there? Two electron pairs. Electron one can be two electron pair will form. Therefore, two bonds or two hybrid orbitals will be get formed. Similarly, the region of electron density, if it is 3, it forms sp, two hybrid orbitals, means one s orbital and two p orbitals. If you go for 4 region of density there itself, at that time what happened? One s orbital and 3 p orbitals, so that what happened? 4 hybrid orbitals can be obtained. Depending upon region of density, hybrid orbitals obtained will be existing. If we are having two sp hybrid orbitals will form. If it is 3, one s orbital and 2 p orbital will form. If it is 4, what happened there? One s orbital and 3 p orbitals will form. So that sp3 hybrid orbital will form there itself 4. sp2 3 sp2 hybrid orbitals will form. sp hybrid orbitals, 2 hybrid orbitals will form. These particular points we have to keep in our mind before going into the concept with examples. These 7 features as well as important conditions are important. Simultaneously, what happened there? What get hybridized within the hybridization process? What will be get hybridized? Sigma bonds as well as lone pairs will be get hybridized. If there are existing multiple bonds within that, one sigma bond will be there. That sigma bond will be get hybridized. Remaining 2 which are unhybridized, pi bonds will never hybridize. And we are saying that if it is having 2 electron density, sp. If it is 3, sp2. If it is 4, sp. 3 hybrid orbitals will be get forming there. Here 2 sp hybrid orbitals, 3 sp2 hybrid orbitals, 4 sp3 hybrid orbitals will form. We'll go into the explanation there.